So thank you very much, Steve, Paul and Joseph. Do you want to just introduce yourself, a bit about your company and who you guys are?
Yeah. Thank you for the intro, Roy, and thank you for the opportunity to come along and speak to you, those of you that are here, but equally to those of you that are joining us online. So welcome out there in the ether. As Roy said, this is not a salesy pitch. This is about education as much as telling you about the Sonatype products and what we can help with in industry. The demands on CEOs, CIOs, CISOs and CTOs and their development teams, application and security architects are ever increasing day by day. The demands to get more out there as quickly as we possibly can is ever increasing across every development organisation that I know of. Open source is mostly 80–90% of most business applications that are built today. So in order to innovate and get stuff out faster, we have to borrow code and thus open source. So we're here to talk about open source and what it means to secure it, to govern it, and to give people the knowledge that they need in order to be able to deliver things safely to their end users. If we look at applications like the NHS app, most of us have access to the NHS app on our mobile devices, our tablets, our laptops at home. We work with organisations much like the NHS in delivering those to some 45 million of us that use those things on a regular basis, much in the same way as banks and banking applications are used, and we help to secure those. We're constantly working with organisations to secure that software supply chain. So the theme of Joe's presentation this evening is what DevSecOps can learn from Elon Musk. And whilst Joe's presenting, perhaps we can all think about how automation aids with agility and bridges the disparate silos of development, of security, of operations, and also allows us to get more out of the door that bit quicker. So without further ado, I'll introduce Joe, and ably assisted by Paul Hall. Thank you.
Steve. Firstly, thanks to the BCS and Roy for having us. Delighted to be here. My name is Joe Burney. I'm a solutions engineer, and as such, I help organizations secure their software supply chain and use open source software safely. I have with me a colleague, Paul Horton, who is actually a former customer, so he has some excellent insight and might have a special treat for us later on. Before I begin, before today, how many people here would have heard of Sonatype? And maybe at home, remotely, people can answer there as well. Okay. And how many people would have heard of Nexus Repository Management? Okay. And how many people would have heard of Maven Central? Okay, so the same two people for everything. But
I'm sure there's probably some online that raised their hands. So.
Yeah, well, Sonatype are the maintainers of Maven Central, which is the open source public repository for Java. And Nexus Repository Manager is one of our flagship products as well. So for everyone at home, if you weren't familiar with Sonatype, you may have been familiar with one of those two things as well. So today, I'm going to talk about satellite technology and SpaceX and Elon Musk, and how they were ahead of the curve in ways if we compare them to DevSecOps. So what can we learn from them today? Oh, lost. Okay, back. So for a long time, satellites were very bulky, very heavy, and they weighed tons, and they're extremely large. So we could compare them to monolithic applications. They took decades to build and launch, and they had a huge amount of different functionality associated with each one. So this is an example of all of the functionality that is in one particular satellite, the NOAA 19. So I won't get into all of the different sensors there, but essentially it had 8 different sensors for 8 different functions. So each of those were customized all for a specific purpose, and everything was completely bespoke. I just see that the audio is not satisfactory. Maybe I'll just try stand closer here. Oh, slides are also not updating for remote use.
It's updated for me.
Okay, I'll keep going anyway. Again, when we have these 8 different sensors for 8 different functions, we're, on this kind of customizable large application, we're reminded of monolithic applications. So then someone smart came along and said, let's make them smaller. Let's standardize satellites. Let's use off-the-shelf components, and let's launch them in a standardized way. Let's make them cheaper and easier and quicker to launch. So CubeSats were invented, and Surrey satellite technology was founded. So where am I going with this in terms of DevSecOps? Well, we had large satellites and monolithic applications, and then we had CubeSats and microservices and containers. So CubeSats are similar to microservices and containers in that they have, a single function. They have defined snippets of functionality and defined units. But as you can see here, satellite technology was actually a little bit ahead of the curve with this ideology. So CubeSats used off-the-shelf components. Components like Raspberry Pis, mobile phone batteries, because they're cheap, they're standard, and they're small. But if we compare that to modern development, we are using pre-built functionality from open source components, from ecosystems like Maven Central, NPM, and PyPy, and a whole host of other public repositories. So we're using pre-built functionality because we want to be able to innovate. Companies need to be able to move fast. And in order to do that, we don't want to waste time creating another logging function. We want to use pre-built functionality and leverage the power of open source. So these stats are coming from the State of the Software Supply Chain, which is a report by Sonatype every year. And actually, there's a new report out this week. But as Steve mentioned, 90% of modern applications is made up of open source. And the reason is, as I've described, companies need to be able to leverage open source in order to be able to innovate and move fast. And the supply of open source is also increasing. At the moment, there's 20, and this is there's a new State of the Software Supply Chain report out as well, so this number is likely out of date. But 21,000 new versions of open source are released every day by the project contributors or the suppliers. The demand for open source is also increasing. So again, this is 2021, but if we could see here, just from PyPy alone, 92% increase in the amount of downloads of the open source components from PyPy at that time. So the supply of open source is increasing, and also the demand of open source is increasing. So back to satellites. So because CubeSats or small satellites were smaller, cheaper, and easier, this means that because they're different, we can treat them differently. So this is an image of the Hubble telescope satellite that is being repaired, and in order to repair it, they had to send a space shuttle they had to launch a space shuttle in order to be able to conduct that repair. If you have a small satellite or a CubeSat, you can just deorbit it. So we can treat them entirely differently. And this allowed for projects such as Starlink and OneWeb. Now, Starlink planned to send 42,000 small satellites into orbit. That's 15 times more satellites that are currently in orbit today. So this is, enabling huge new avenues, for this type of technology, because these satellites are cheaper and easier and more standard. This is where our friend Elon comes into the equation. So he obviously founded Starlink, and he also invested 10% into Surrey satellite technology as well when it was founded. He was very interested in garnering interest back into the space race, and his initial idea was to basically grow a greenhouse on Mars. And what he did, that actually transpired into a colony on Mars, but what he did was he looked at the entire life cycle of sending stuff to space, and he could compress the cost of every single part of that life cycle, that part of that process, except for the rockets. Now, at the time, another way we've standardized on small satellites is that we were launching them in a standardized way. So one of the things that was happening was that, and this is the Viper, which is actually an Cold War intercontinental ballistic missile, which was converted into a space launch vehicle, and they would launch numerous small satellites into space using this. So essentially what they did was they screwed off the nuclear warhead, decommissioned it, and then turned it into a space launch vehicle. And Elon was very interested in this method of transportation, so he actually visited Russia with the purpose of buying 3 of these intercontinental ballistic missiles. And it didn't go very well. And he was offered just one ICBM for 8 million. So he came back with his tail between his legs. And this is when, in 2002, he decided to build his own rockets, and he founded SpaceX. So, the interesting thing about SpaceX is they took a very DevOps agile approach to building rockets. So, what this meant was that they moved fast. They moved fast, and they iterated, and they broke things. So these are some of the early launches of SpaceX rockets, and they had a lot of failures along the way. I actually think this one works out. No. But the thing is that it is okay to fail in a DevOps environment. DevSecOps, it captures the need for security to be everywhere, but not in the same way everywhere. We can move fast, and we can break things. We just have to be able to control where things fail, control the impact of that failure, and learn from those failures. So, SpaceX had tremendous success with this DevOps agile methodology. Massive payloads such as reusable landings, and we all remember Starman. But arguably the biggest milestone of this timeline and SpaceX's success is the crewed mission. So now people's lives are on the line. Therefore, safety is absolutely critical. So there is a subtle difference between safety and security. So safety being the state of being protected from danger, and security being the state of being free from danger. And actually, how we safety is closer to how we approach security in DevSecOps, because we can't be free from danger completely, because new zero-day public disclosures are happening all the time. There is one today, Commons text, that's being disclosed, and it's in the news at the moment. There are upstream supply chain attacks happening, protestware, I'll get into in a moment. So it's not that we need to be completely free from danger, because it's just not possible, it's unrealistic. But how we react to that danger, that's what's important. So SpaceX went from a move fast and break things company to a reliable production systems company with people's lives on the line. So they did move fast, they iterated, and they learned, and now they're able to release something stable and reliable. So this is an excellent model, and what we want to do here today is see what we can learn from how they took that journey, the journey of moving fast, breaking things, and then actually having people's lives on the line. So one thing that we did was we took a look at the safety standards that they had to follow in order to send people to space. So these have been created over decades by NASA, and they're human rating requirements for space systems. So these are the safety standards that SpaceX would have had to follow and meet in order to be able to send people to space. So what we're going to do is look at individually some of those standards and see how they can apply to DevSecOps. So this specific standard states that the space system shall provide the capabilities to sustain a safe, habitable environment for the crew. In other words, no exposed sharp edges, no exposed high temperature surfaces. So likewise in our applications, before they go into production, we don't want any high CVSS scores. We don't want any bad vulnerabilities, like for example, log4shell or Commons text. We may not want any prohibitive licenses, like AGPL licenses. We may want policy preventing our applications from being released with those banned licenses. And this is a stat from the 2021 software supply chain, and this has increased again. But we need to be protected against upstream supply chain attacks. So this is, different from a public disclosure. It's far more sinister, where actually bad actors are injecting malicious code upstream into projects. And one of the biggest examples last year of this was dependency confusion or namespace confusion. So this relies on a bad actor learning the names, determining the names of your internal libraries in your organization, and then releasing malicious versions of those components on public repositories. So then that using the convention in a lot of programming languages to download the latest of a component, you could automatically download, potentially automatically download malicious version of that component onto your machine. So these types of attacks are increasing. As you can see, that's 650% year on year. It's now 720. And we need protection from those type of attacks. So this safety standard states that the space system shall be designed to tolerate inadvertent operator error without causing a catastrophic event. So in other words, an operator should be allowed to make capable or should be able to make a small mistake or an error without a catastrophic event happening. That makes sense, right? So similarly, there's an upstream supply chain attack called typo squat, which essentially preys on a developer making a small typing mistake, and bad actors are uploading malicious versions of popular components with basically the same component, which is a small typo made, so that they're preying on those developers making small mistakes, downloading malicious versions of those components with a small typo. We also need protection against this. We need protection against developers making small mistakes like that. So this standard states that the space system shall provide the capability to isolate and recover from faults identified during system development or mission operations that would result in catastrophic event. So we need to be able to recover from faults. So if we compare this to modern development, we need to be able to find and remediate from vulnerabilities at every single stage of the software lifecycle. And in order to be able to get feedback at every single stage, we're going to need to be able to automate. And in order to be able to automate, we're going to need precise and accurate data. Because if we don't have precise and accurate data, that will not, we just won't be able to automate, and we won't be able to get that feedback at every single stage of the lifecycle. Because the sooner we find that fault and know where it is, and the sooner we're able to fix it, obviously the better. So this standard states that the crewed space system shall provide the capability for autonomous operation of system and subsystem functions, if lost, would result in a catastrophic event. So basically this is saying that if mission control lost communications from the crew, that the crew could actually take over and have autonomous operation. So if we consider mission control as the security team, and we consider the crew as developers, we need to be able to give autonomy to the developers, and we need to empower them to drive security from the get-go, from the beginning. They need to be able to drive security. That is the concept of shifting left and allowing developers to pick good open source components early. The space system shall provide the capability to utilize health and status data of critical systems and subsystems to facilitate anomaly resolution during and after the mission. We need to have in our applications all of the data around what open source components we're using. So one way of doing this is by having a software bill of materials for every single application that you build. So we will have, if you do this and you automate this, you will have full information on all of the open source components and all of the versions that are in your application. And that way you can trace back if there's ever an issue, where is the vulnerable version of that component? Where is it used in all of my applications? It also allows you to find and fix those very easily in all of your applications if you have full transparency into all of your open source risk in your organization. Cyclone DX is the recognized standard for software builds and materials in applications. And Paul Horton, who's here with me today, is a project contributor for the Cyclone DX project as well. So that's interesting. We'll talk about that later. But how can the Nexus platform fit in and help you with all of these standards, safety standards that we've learned from? Well, on the screen here, we can see a typical software lifecycle. So a developer is pushing to source control, and then their project gets built. It gets pushed to a repository, and then after some testing, that goes into production. So in order to build their projects, they are using open source components, as we have discussed. So they're using components from NPM, Maven Central, PyPy, and here's where Sonatype fits in. So we have a product called a Nexus repository. So this is it manages libraries and build artifacts. So one function of this is it would host all of your build artifacts that you've generated from your developers, but also it can proxy and cache all of the open source components from all of those public repositories. And this is an interesting product as well, because we have an open source version of this. So, any of the students that are listening in or here today, this is something that they can install on their machines. It's open source, and all of their builds can be cached locally. And obviously, when you cache them locally, you have a single source of truth. All your developers and CI servers are pulling those open source components from the same place. And if they're cached locally, then all your builds are going to build quicker as well. So the next component here, which is the F on the screen, is Nexus Firewall. So what this does is it enforces policy on entry when a developer tries to pull down a new component. So if it is a known vulnerable component, you can enforce policy to block that component. If you, for example, you can block all components with a CVSS score of greater than 9. But also what this does, it protects you from upstream supply chain attacks. So we will also help protect you from unknown vulnerabilities. So we have a malware detection algorithm that we use that will essentially, we are looking at every single commit, every single new project, and we're running this through AI technology to find any indicators of compromise. So any release that looks suspicious, like it could be an upstream supply chain attack, we can block that, we can quarantine it until our research team gets an opportunity to review it. And then we can automatically release that into your pipeline to be used. So this is, Sonatype are the only company that have this kind of technology, and it would protect organizations from upstream supply chain attacks like typo squatting, like we discussed, dependency confusion, and protestware as well. So Nexus Lifecycle is the next tool that I'd like to talk about. So here is when we are integrating and automating across the entire software lifecycle. So a developer will have contextual information without having to context switch right in their IDE. We will have feedback from pull requests and automated pull requests in the source control. And what we can do is we can integrate into your CI builds so that we can basically automate generation of a software bill of materials for every single application that you have. And what we can also do is a feature called continuous monitoring. So what that allows you to do is essentially when an application is in production, if a new vulnerability is found that violates your company's policy, we will immediately let you know about that vulnerability, let you know every application that it exists in, and also tell you how to remediate that. All of this is done by our proprietary data, so powered by Nexus Intelligence. So we're using superior open source data. It's accumulated using AI from over 40 different sources. So not just NIST, not just public repositories, from GitHub commits and blogs, everything from there. And then all of that data is manually curated by over 65 researchers that are working specifically to, first of all, ensure that that data is accurate, and secondly, give you contextual information recommendations and any mitigating factors alongside any vulnerability that's there. So you get huge amount of information, contextual information from any policy violation that you get to allow you to action on any of those policy violations. So, in conclusion to this section, DevSecOps does capture the need for security to be everywhere, but we can still move fast and we can still iterate. But let's learn from people that have brought us to space and get software out quickly and safely and keep everyone safe while we're doing it. So the next part of this presentation, I'm going to introduce Paul Horton. So he is Cyclone DX project contributor and a former customer. So he's just going to give some context, and then we will field any questions about the presentation that we've had so far.
Hi Rob, hope you can hear me online. I'll move over here just in case this one is the microphone. So I used to, I've had many roles over the years, and I guess we were talking about DevSecOps being a name that's now given to something that didn't have a name, and various things over the years. I've been in that arena for longer than I care to admit these days. Time in consultancies on large projects, but most recently, I guess, before Sonatype, I headed up the DevSecOps function for what became Virgin Money. I've got a lot of real-world experience, and we did purchase Sonatype products there. One of the things that is difficult to appreciate with this, unless you're actually on the ground doing it, is the scale of the challenge. We can look at various numbers we've got in public data sources. So the NVD, we're on to our almost 43,000 vulnerabilities recorded in the NVD this year. Okay, and that number's gone up relatively exponentially since about 2007 when that kind of started. But if you add all those up, you get to somewhere around a few 100,000 now. Sonatype's data sits in the millions of vulnerabilities, and knowing you've got a problem is great. But then if you're in a regulated industry, the next question is, what are you going to do about it? Because once you know about something, you have to do something about it. And that's really where Sonatype comes in, because one of the great advantages to our data is we give you the advice. Okay, it's not just you've got a set of problems and they're all here, there and everywhere, but we're going to give you the advice about what you can do about it, or how to mitigate it, because open source is very complex these days, as I'm sure many of you know. So, as Joe mentioned, I one of the core maintainers at Cyclone DX. For those that don't know, that's one of the standards for codifying bills of material. We talk about SBOMs in open source because it's software bill of materials. Cyclone DX allows you to codify all sorts of things as bill of materials. So you might make pacemakers. Okay, so that's a hardware bill of materials. That's still codifying what went into something, where it came from, how it came to be. And that can be extended to codify services. So SaaS bombs now are a thing, and there's other things in the works for next year with Cyclone DX. So we talked about it on earlier with a few people. That's looking at how we can codify reproducibility of something, or codify how you got to something as a way of attesting that it is what you say it is. And this is all driven out of some of the legislation that was mentioned in Joe's talk there. So this all started with really President Biden. His first act was to pass a cybersecurity bill. Lots has been going on in the US. ENISA in Europe has also picked up the baton. David Cameron actually very silently followed suit with Biden. didn't make the press in the UK, but that did happen. So there's lots of stuff about requiring software bills of material now to sell to US departments of defence, for example, and that's getting tightened further at the minute. So not only do you have to say what does your software contain, but you also have to acknowledge where you know there are known vulnerabilities, and maybe there's a mitigation for it, maybe there's not. But you have to be able to demonstrate and declare that, and there's all sorts of frameworks like SALSA as well that are helping to standardise this sort of topic. So it's fascinating. Joe and I can talk about this for longer than we've got, and I'm sure there'll be questions. So we'll hand it over. Roy, you can keep us.
Were you able to talk about the new thing that's coming out?
Yeah, we can do that now, or do you want to?
Let's do that
Yeah.
now.
Okay, we'll. So.
Stop share.
Has Andy got a question? Is that why he came up?
I might just be as the first in the outfit.
All right, okay.
I don't know.
So one of the things we've been asked to do is share, kind of free tools. How can people who are interested, get involved without, maybe access to enterprise grade tools. So we've got a number of tools on our website. So we've got Sonatype Lift is you can't even buy this product from us right now. This is it's a year in the making up to this point, and it's still got some way to go. But this is what we call first party code analysis. So it's not looking at the open source you're borrowing, the 90%. It's looking at the 10%. And it can also do some of the software composition analysis as well. So this hooks into GitHub right now. So if you've got a project on GitHub, a free project, you can go and add Sonatype Lift to that. And it's very developer focused. So that hooks into the repository. It'll comment on your pull requests. It's going to give you very low level analysis of the code you're writing in the different languages. So runs tools like SendGrep and various other things for different languages. And the feedback we're getting there is that that's really useful. So unlike other tools in the market that do third-party code analysis, one of the unique points of Sonatype Lift is that we also measure the rate at which developers pay attention to our recommendations, which allow us to prioritize those recommendations over time and reduce the noise. One thing developers don't like is a lot of noise, right? We're a sensitive bunch. So that's coming soon, but you can also just go and use that for free right now on any project on GitHub. You already mentioned Nexus Repository, OSS we call it, so that's the free version of Nexus Repository. I've got a running bet with some of my ex-colleagues that nearly every enterprise in the country has got an installation of Nexus Repository somewhere. It might not be known about, it might not be declared, but it's pretty prevalent. We also have a free data service. So while Sonatype's data is our biggest USP and we protect it at all sorts of costs, we also run something called OSS Index. So that's a free data service. Now actually, we've changed that recently to include all the Sonatype discovered vulnerabilities that are not on the NVD. So if you go and scan a project using some of our other free tools, which I'll get to in a second, you can connect that to OSS Index, and you'll get some free vulnerability information. It doesn't include our tailored recommendations about what you can do about it. That's the paid for tonight. But it is going to tell you you've got the issues and you know where you stand. If you want a sneak preview of what Nexus Lifecycle looks like without getting into product trials and things, we've also got our Nexus Vulnerability Scanner, which you can download for free from the website. I think it allows you to do 3 application scans without getting absolutely hounded by our sales team. So you can try that as well. And then we've got a whole bunch of other projects, some of which, again, I'm directly involved with. So these are tools that we've written over the years, and most of these talk to our Nexus Lifecycle product for our enterprise customers. But if you don't want to, you're not buying that product, you can also point them to OSS Index to get the slightly lower quality data. And these are often have come about because when you want to analyze a project, okay, it's just not that simple to identify what went into it, right? You might think that's the case at the first glance. You know, maybe it's a Maven project, you've got a pom.xml. Everything should be in there. Developers do tricky things sometimes, and that isn't always the case. Isn't always the 100% truth. So a number of these, particularly Audit.js, which is a JavaScript project scanner. There's some weird magic that can happen in JavaScript projects that I really don't understand. Audit.js deals with all that. Jake is one I know about that looks at Python applications or Python. I can't read the full question there.
So I'll pick that up.
We'll pick it up in a second. Okay, great. So there's a whole bunch of different aimed at different languages, essentially different project categories there. So all free to grab, all free to use. What I will do is now move on to get rid of this. This is the first time I think anyone at Sonatype has shown this live. So hopefully it hangs up. So this is an experimental product that has only just become publicly accessible. So you can go and request access to this today. You have to fill in a form to get a token, just so we know who's trying it out. But one of the things that we're always asked, or people come to the Slack at CycloneDX and say, "It's great, I've got an SBOM, but how do I look at it? How do I, as a human, look at it and understand it?" Because by their nature, software bills of material are machine-readable documents. They are JSON documents, they are XML documents. And there's a lot of information there, and it's very difficult for a human to read that. So Bomb Doctor is kind of a potential answer to that, and it's also pulling from our proprietary data. So it's helping you not just visualize what's in your SBOM, but also give you an idea for how good it is and how ready it is to go. So I'm going to upload a purposely bad CycloneDX document here. So this is, for any of the security folk out here, you've probably heard of WebGoat, which is a purposely vulnerable Java application for security kind of testing and experimentation. So I've generated the CycloneDX for a legacy version of that. Okay, and this is kind of what you start to see. So it's a huge graph of all the dependencies, and we're giving you a kind of a score, okay? Because ultimately, when we start to talk to our risk officers, our security officers, right, the detail is lost, right? You know, that's not the point. We always have to find a common language, and the common language is normally numbers in some form. You know, is it good or is it bad? So we're trying to aggregate all that up based on our information, and we're trying to make it fun. Which is also a slight challenge with these topics. So we've got the doctor in the bottom left, and so you can just ask the doctor to give it to you straight. That's the whole point of this. So you can get an idea, and this is telling you absolutely do not put this application into production. Right? It's full of issues. But of course you can drill into this and understand more about. Why are there issues? What are the issues? So we tend to look at the individual projects now. So yes, you define some dependencies. They have dependencies, and of course we have to look at the entire graph of this. But we look at how well projects are managing their dependencies. So the biggest indicator of open source project hygiene that we've been able to find over some horrendously complicated data analysis, which is coming out in the State of the Software Supply Chain report tomorrow. I've been told not to share it today, otherwise I'll get very told off. But what that is you can look at all sorts of metrics on projects. How many people are contributing to it, how often they release it. But actually, the biggest indicator, the strongest correlation we found, is how quickly a project updates its dependencies. Okay, so if that project is very good at regularly keeping its dependencies up to date, It's not about specifically avoiding known vulnerabilities, it's about the cadence at which they update their dependencies. That's the strongest correlation for a good project that's going to have the least number of vulnerabilities. So we're looking at that, that's what the shield there is. We've also looked at relative popularity. So, you know, across, we run Maven Central, as Joe mentioned, right? So we've got a unique amount of data for Java specifically. How popular is this particular cryptography library versus another one, okay? So we can provide, you know, aggregated insights at that level. And of course, security vulnerabilities, so known security vulnerabilities at this point. So one phrase Joe didn't use that I always like to use, open source aid is like milk, not like wine, okay? You know, we know something's great today, tomorrow, you know, Log4j, 9th of December, it was lovely, 10th of December, it was absolutely terrible and everything was on fire. So that's how we like to look at this, and that's why lifecycle with its continuous monitoring actually helps protect you, about, you know, without active having to do something about it all the time. So that's a sneak preview. You know, please feel free. We can share the link with this after the session. We can drill into any more stuff on that if you want to. But I think that's probably all the surprise from today. Any questions on the chat?
Okay, so yes, so let me come up here and I'll so that I can hopefully be heard. But so we've had a few questions come through,
Okay.
and I'm sure we may well have some more here. And I've got a couple of things that I noted down. So let me just go to the couple of questions that we had through on the chat. So one of the questions from Stuart Ward was about integration of products from your company with other typical software development tools, things like Jenkins, GitHub, what have you. What can you tell us about that?
So yeah, our Nexus Lifecycle in particular is designed to fit into all these tools, right? We've got native plugins to make it really easy for all the obvious continuous integration tools. So Jenkins, your GitLabs, your GitHubs, you know, Tecton if you're on OpenShift. All these things have native plugins. But the kind of sad reality, if I'm very honest with you all, is that whilst a one-size-fits-all approach is very appealing and everyone wants this ideal, when you get into some of the realities of software development and these projects, particularly monoliths and some of these things, a one-size-fits-all scanning approach doesn't give you the full picture. So you...
Sorry, just to interrupt you,
Yeah.
can I just ask you to just explain what you mean by one-size-fits-all scanning?
Yeah, absolutely. So, for example, you may you check out your project from Git, okay, and it may be a Java project. So we may go and look for Maven POM XML and interrogate that. That's a very simple way of scanning a Java project, okay, and the reality is that might not give you the actual answer of what gets built. So there are other scanning technologies, ways of scanning using our product. So we've got a Maven plugin, for example. Now that will give you the absolute God's honest truth if it's a Maven project. So you have to understand the context. If you're scanning a Maven project, you need to know to use this particular method. Now that's an edge case for different languages. Probably 90% of any project in any language, you could just use our standard scanner, so like a standard CLI scanner, which is what is wrapped up into the Jenkins plugin, the GitHub integration, GitLab integration, etc., etc. And with almost no configuration, you can scan anything. So generically, there's an answer. There's always an answer with Sonatype. We provide an immense amount of flexibility for integrating scanning into your environment. And everyone's environment is different, everyone's tooling is different. So we try our best to make it easy, but also support all those different edge cases. Hopefully that answers.
Yeah, and one thing we can do as well is just follow up with our integrations page when we send down the bomb doctor information so that people can look at all the different tools that we integrate with. And along with that, we also have REST APIs in our IQ server, which is the lifecycle tool and firewall, and also the Nexus Repository Manager. So you can integrate with external tools using the REST APIs as well.
Okay, I'd like to turn it around to slightly more generic advice as well. So I think what I've heard you say is whatever technology you're using, even Sonatype technology, you need to know what you're doing with it. You need to know how to use it to get the best out of it.
Absolutely.
And I'll be cheeky, and it might be that sometimes, you might need to complement Sonatype technology with other technologies to cover the full remit of all the different things that you're looking at out there. Is that being too cheeky?
So I think maybe a little bit,
Yeah,
because
yeah.
the problem breaks down into two parts, right? Which is you have to accurately identify the things in your application or the open source, and that's the bit why we'd say the scanning aspect is potentially. May use a Maven plugin if it's a Maven project. We've got a Gradle plugin for Gradle projects, etc., etc. Once you've accurately identified everything, you need to match that against some high quality data. So the other aspect of this, probably to go back to your devil's advocate question there, is you could have another tool, nothing to do with Sonatype, generate you a Cyclone DX bill of materials, okay?
Mm-hmm.
And you could pass that to our product, and we can tell you what we know about the things in that.
Because you might already have it.
Exactly.
Yeah.
Yeah, and there are plenty of other tools out there that do it for, maybe Docker images, for example, right? That's a whole different complex area for scanning and different ways of delivering them as well sometimes. So you can absolutely do it that way. And as Joe mentioned, full REST API is available for all those things.
Okay. All right. Had a couple of other questions come in, so let's cover those before I go on to any other ones. So there was a question from Olu, where he says, where do vulnerabilities in the described systems still exist, and what are the next improvement steps? So
I think, I saw that question. So I think what he said is, for some that we uncover, they get taken down, but for others, they remain out there. Why is that? So maybe you want to explain why Log4j still exists as such, because, so
you're interpreting it to say, why do things still get left behind? Is that what you're saying? Or
why are still things out there in the public repos? I believe
that could be what's being asked. Answer that to start with.
I'll talk about that because it's an interesting philosophical problem, really. Okay. So Sonatype operate Maven Central. We refer to ourselves as the custodians of it. It's a service we provide to everyone to publish their Java projects to. Sonatype does not own those things. We provide the service, the distribution, and we pay for it all as well. It's not our right to take down someone else's application. And just because something has an exploitable thing in it doesn't necessarily mean it's bad. Log4j is a really interesting example because the actual vulnerability, there was 5 or 6 CVEs in the end that were raised against that. That actually was a feature request that was put into Log4j. So it's not for Sonatype in that case to say that is acceptable or not acceptable. This is risk management. It's how you're using it, defense in depth. All these other things play into an organization's risk approach. And
well, I think that might be actually what's behind the question. So I wonder whether what's behind the question is saying where you've identified that you've got some vulnerabilities in maybe some open source components, until you can purge those open source components or replace them with something that doesn't have a vulnerability. Can you what's the advice for what kind of things can people do to live with that situation? Because it might be quite difficult when you've got a very complex stack of code with multiple layers of dependencies. Are there any common strategies that you've seen that people follow to try and live with that horrible situation where they can't quite fix everything yet? Because that's the reality, isn't it?
It is the reality, and it's a very difficult. There is no generic answer to that because every vulnerability is different.
Yeah. Can you think of some examples of what people have done?
Oh, absolutely, and we publish this in our data. So, removing a component, because it's got a CVE, is not always the only answer. It's very common, particularly in Java in the Spring framework. Spring framework's got an almighty amount of configuration you can pass into it. So it might just be you can tweak a little flag,
Yeah.
and that whole part of that library is disabled.
Okay, so there might be some settings you can change,
Exactly.
which mean it's not going to use that feature that's got the vulnerability in it.
Exactly.
Yeah.
So that, and if that's a possibility,
Yeah.
our security data team
Yeah.
add that to our
Yeah.
remediation advice.
Yeah.
That's
Okay.
not always possible.
No, but I think that might be where Ola was going with his
Yeah.
question. There's a question from Ian who says, and this is a slightly different question now, which says, currently, what do you think is the most commonly used open source software for developers who are trying to protect personal identifiable information? So, protect, you can treat protect in whatever way you wish.
Yeah, I'm not quite sure I understand the context of that question per se.
Okay. Well, I mean, protect could be to help identify. It could be to stop data leaking. It could be, to any number of different things. Yeah.
Yeah, it's a very difficult one because you're defining what PII is and isn't. In the legal sense, it's very clear, right? But as a computer, it's a little bit more challenging. So we have got another product which we don't talk about very much, right? Which only relates to Kubernetes environments, which can actually see all the traffic that's going on and look at it. And ultimately, those types of things are what we call data loss prevention.
Yeah.
Normally, firewalls or web application firewalls provide that sort of functionality at your perimeter or whatever it is in the network. You can do similar things, to Kubernetes level.
Okay, and I'm going to push you on the question. Because the question was specifically asking about open source, not necessarily a Sonatype product. So,
Well,
from your experience, have you come across anything out there that's open source that might help people if they were looking for something like that?
so the reason I was talking about that product
Yeah.
is actually it's an open source.
So that came
product.
from the open source family background. Okay.
Yeah, so it's a product we partner with SUSE on. Okay.
Okay.
So SUSE SUSE bought a company called Neuvector,
Yeah.
which you've probably heard of. Neuvector have honestly a class-leading product, or it's no SUSE, and that's open source. You can download and run that on your Kubernetes cluster yourself.
Okay. So that's Neuvector, did you say? Or
Well,
what?
it's
Or it came
SUSE now because
It's
SUSE
SUSE.
bought Neuvector, but I think it's still under Neuvector's GitHub accounts.
Okay. So the answer is go and have a look at that one.
Absolutely.
That could be a place to start,
It
depending
works.
on what problem you're trying to solve.
It does, yeah,
Yeah.
absolutely.
No,
And
but
OSS index as well, which Paul already talked about.
okay. So how does that help from the privacy point of view for the personal information?
Well, just from a personal information point of view, so if you're looking after all of the vulnerabilities that are in your application,
Just
then
knowing what's there.
knowing what's there, you'll reduce the
Oh,
the
okay.
risk.
So as a tool, it's a tool to help you go and find out what's there and be aware of the risks.
Yes.
Yeah, fine. Okay, because there's different answers
Yeah.
depending on whether you're trying to prevent, be informed, or detect.
I think the
Yeah.
key there is that you get a huge list. It's knowing what to do with the list.
Which is back to
Yeah.
I think one of the earlier questions. Yeah. Okay. Just a second. I'm just trying to get back to the list of questions that I had. So I had a couple of other questions that I'd noted. Okay. So you can make this specific to your products or generic if you wish. I don't mind. But sometimes people talk about clever automation which does detection of bad things. And I think the premise of what you've been talking about tonight is this job is so complex, you need technology to help you. You need technology, like you just put up a graph there for like one application, which is probably realistically a relatively small application. Yeah, and if you were to do something like this for a large business application, you'd be staggered at the complexities of what's out there. So you need technology to help detect, advise. What's your thoughts as to where the technology is going for remediation? Are we going there, or is that
I'd say
too futuristic?
prioritisation first. It helps
Well,
to
that's a
prioritise.
good answer. So prioritisation might be the next step. Yeah.
Prioritisation can be the next step, and
Yeah.
often that's what a lot of organisations look to do, right?
Yeah.
Other tools out there, free ones, some of the free ones, right? If you run those, you'll get, 1,000 problems. And now what do you do with 1,000 problems, right? Which ones do you go after first? Because you can't go after them all at once. So yeah, prioritisation and organisations have got different ways of doing that, right?
Yeah.
You know, different, and the other thing is the context of the application is also critical. That, you know, that's in, because when we were at the bank, right, you know, we've got some, you know, applications that sit really deep in the network. They don't process any payment data, personal information data, so they're probably not high on the list of applications to go and spend a lot of time on in terms of remediation. Conversely, when you've got, you know, an iOS app that you publish to the App Store and everyone downloads it, it's considered software distribution legally. You probably want to know about the legal ramifications, and you probably care about those considerably more. So I think context is probably what I would say is the thing that organisations always should have in their mind when they get these lists of problems, or, you know, they look at the issue at hand.
Okay, thank you very much. I mean, we've run over a little bit. I'm just conscious of people on the line here online. So let me just check that we haven't missed anything else. So thank you very much for the answers. Is there anything else that anyone in the room wanted to raise? No, so that's okay. Yeah, yes, Papa.
I was just curious to know, how are you scanning your own application to make sure it doesn't have any vulnerability?
So do you take your own dog food? Yeah.
Very much.
Yeah, or your own, yeah.
Very much.
Yeah.
And that, honestly, that stops us releasing our software sometimes.
Yeah. So you do it for yourself as part of your own development pipeline.
Yeah.
Is that what you're asking?
Yeah, I was
Brilliant.
just curious to know
Yeah,
how
yeah.
you're scanning
Yeah.
your own. Is there
Even
any
our
stuff-
open source tools, I can't release them unless they pass our checks.
Brilliant. That's good. Okay. Anything else from anyone?
The only thing I would say, Roy, is if anyone does have any further questions, I think you can
Yeah.
certainly pass
come
on
to
our
me and we can
contact
pass them on.
details
Sure,
anyway.
Sure.
And we'd be more than happy to dig a little bit deeper with anybody if they really want to do so.
Yeah, okay. I put a link to the open source
Yeah.
tools that you put up there,
Yeah.
Paul. I put that in the chat.
Perfect.
Now, if you're in the room, you won't see that. So is there any way you could append that to your slides?
We'll add an extra slide with
Yeah,
some links.
and similarly, if we're allowed to see the link to your tool with the Mad Professor, that would be wonderful, yeah, or the Doctor rather,
Bomb Doctor, yeah?
because then when we send out the slides, people can then get to those.
Yep.
Yeah, that would be
Absolutely.
great. Okay, well, look, thank you very much, Paul and Joseph. That's great. Okay, and thank you, Steve, for coming along and arranging this.
Always.
Okay, thank
Pleasure.
you.
Thank you very much.